So that was awesome. All right. What is our domain? Grace? Okay. Someone have something different? Abigail? How many of you had that? Okay, so the two options right now that we have heard of were negative infinity to 5, and then, Abigail, what was yours? Negative infinity to, and then we had that. Anyone have something different? Finn? Okay. Anybody else? Okay, so talking about domain from left to right, okay? So take your pencil, left to right, negative infinity, right? To where? Am I going to 5 or am I stopping at 2? 2, but what's happening between those two? Is there a gap between 2 and 3? Yes, so we have to split it, okay? The reason, Finn, what you mentioned, which is also correct, however, you're going to use that for here, okay? So, domain, negative infinity to 2 with a parenthesis, because all my x values are being used until 2, union, it jumps to 3 to 5, okay? 5 is where it ends, okay? Yes? We're looking at our ranges, which are here. There's a closed circle overrides an open. So that's negative 2, and then it continues. So every value is being used from negative infinity, including negative 2, negative 1, 0, 1. 2 has a parenthesis because it's an open circle. Okay? All right? Now, flip side, domain of, or intervals of continuity, is splitting up each graph by a piece, and it doesn't matter brackets or parentheses. It's parentheses only. So Finn mentioned the domain, the interval of continuity. However, we just have to remove those brackets and put what? Parentheses. Okay? So the domain, or the interval of continuity, and remember, interval of continuity is because you have to pick up your pencil. Okay? So negative infinity to negative 2. I have to pick it up, then move it to negative 2 to 2. Pick it up, move it to 3 to 5. That's why it's intervals of continuity. Okay? Does that make sense? Do you guys like see the difference between the two? Okay. Great job, you guys. Range, there was a lot of discussion about range. Okay. Let's see if anyone has. Rory. Perfect. Okay. Negative infinity. Okay, so we go from bottom, right? Negative infinity to 2. 2 is going to have parenthesis, union, and then how'd you put the 3? Okay. 3 would actually be in brackets because 3 is being used here and here, which closed circle overrides an open. Okay, Liz? Only use parentheses. Okay? Anytime, and that's a good point, and I'm glad you brought that up. Anytime you mention interval, think of intervals as increasing, decreasing, constant. Intervals of positive and negative. We've used parentheses for the whole thing. Yeah, John. To 2 is here, then it jumps. It doesn't continue. So all the decimals in between 2 and 3 are not being used. It's here. Look, if I go across, and this one is, okay, you got it? All right. So when we, yeah, because 3, 0, 3, right, is closed. It's a closed circle. So closed overrides an open. All right. So we will continue awesome conversations and talking to each other as well as clarifying. So good job, you guys. We'll break right now. Go to lunch. Good. Okay. So the next two questions are just graphing. All right. So when I'm graphing a line, where do I start? John. The y-intercept, which is 0, 2. Okay, this is our y-intercept. We should all know that. And then what? Then what do we do from y-intercept? Go ahead, John. Good. Down 1 and then over 3. And we could go in the opposite direction as well. Up 1 to the left, because we know this is a linear equation that keeps going forever. Okay. How about B? Where would I start? Yeah, Sam. Right 4, down 1. So what is our vertex? Because this is a quadratic. So what is our vertex then? Yeah, Laura. 4, negative 1, which is exactly right 4, down 1. Okay, and then the A value is 1, so we could use the trick. Up 1 to the right, up 1 to the left, back to the vertex, up 4, over 2, and then here is our quadratic. Okay, then number 3 was coming up with equations. Okay, we have, and this is ongoing, what is my equation here? Campbell. Good. Y equals negative x plus 4. You could do two things. As you look at it left to right, you should have a negative slope. You know your y-intercept is 0, 4, and you could go down 1 to the right to see that the slope is 1 and it should be negative. Or you could choose 2 points to find the slope. Find the slope, then add the y-intercept. Okay. How about number 3? What's our quadratic? Yeah. Excellent. Good job. Okay. And you said this perfectly. Okay. This is a quadratic pointing down because it's a reflection. On some of your practice, I saw x squared here. Okay. Remember, it's outside the parentheses if there's an h value. Okay. So the reason why we did this is because we will be graphing the library of functions on a restricted domain. Okay. On a restricted domain. A restricted domain is a portion of the graph's domain which we will be given an interval notation. So we're going to take full negative infinity to infinity. We're not looking at the whole thing. We may look from negative 2 to 4. So that's the only piece of the graph we're looking at. Okay. Recall, if there is a bracket, then there should be what? Circle at that location. If there's a bracket, what type of circle should we have? Closed. Good. I'll give you guys much room for that. If there's a parenthesis, then there should be what? Yep. Open. Good. It's also called a hole, so meaning there's a hole in the graph. For example, if we restrict the domain 3 to 9, it means the graph should only be shown on x equals 3 point with an open circle to its x equals 9 point with a closed circle. Okay, so let's try some stuff here. All right. So we need to calculate the y values of the points for an accurate graph. So if this is our restricted domain and we're given an equation, we will plug in 6, find a y value, that would go here, then plug in 8, find a y value, which would go there. Okay, so we're going to try an example here. All right. Breaking down the directions. We need to graph. What type of function is this? Charlotte? Good. Absolute value function. Okay. That has a vertex of what? Yeah, Abigail. Careful of this new function. Okay. Grace? 3, -5. And then from points, because we have a restricted domain, when x equals 0 and x equals 5. But in order to find the y, what do I have to do? In order to find the y value. Yeah, Josh. Good. So we're going to plug in these x values to the equation. Okay. So we do 2, 0 minus 3, minus 5. Okay, what is my y value that is going to be paired with 0? John? 1. We end up getting 6 minus 5, which is 1. So we know the vertex is 3, -5. Now, is 0, 1 going to be an opened or closed circle? Yeah. Closed, good, because of the bracket. Okay. Now we're going to input 5. And what do we get for y value? Well, -1. Okay. So is 5, -1 going to be opened or closed? Yeah, Charlotte. Open. Okay. So we could start with the vertex, 3, -5. Okay, that's our vertex we know. We also know closed circle at 0, 1. An open circle at 5, -1. Okay. We could connect. We know it's an absolute value function. We also know absolute value uses what? To graph it. What does absolute value use in order to graph the function? We could connect, yes, but to be accurate, what can we use? For absolute value only. What can we use with that number? Sam? You could use the t-chart, but we could use for absolute value the slope, right? Slope is used. So from the vertex up to either side. Okay. And that is our piece of our absolute value graph. Yeah, Liz? Because there's a parenthesis around 5. Okay, so this is what closed and open. Okay, and for absolute value, you could use that a value as a slope or plug in x values that are between 0 and 5. Yeah, Grace. How do you find what? Absolute value, it's the a value in front. Okay. Okay. For number 2, what type of function is this? Well, it's a quadratic. That has a vertex of what? Bianca? -1, -3. Okay, -1, -3 is our vertex. Now, we need to find from point -3, so this one's going to be open, to 3, which will be closed. So, we have to plug in -3 to find what our corresponding y value would be. Okay, so take a minute to go through and see if you can figure out our y value. Okay, what is our corresponding y value? -3 what? Yeah, you. -1. Good. Because 0.5 is what? 1/2, right? So 1/2 -4 squared minus 3. I'm missing a negative somewhere. Okay. 1/2 times 4 is 2 minus 3. That's how you get the -1. Okay. So you have -1, -3 is your vertex. -3, -1, which is open. And then we also have to do the same thing with 3. Okay. So if you plug in 3, what is your y value? Campbell. 5. Good. So we have a closed circle at 3, 5. Okay. So here, to find the exact graph, you could plug in x values to see. So you could start with 0. Okay, see what you get. Okay, you could do 2. We know that since it's a quadratic, it's going to look something similar like that as a rough sketch. Okay, I did a rough sketch because of time, right? So again, this is just getting familiar with restricted domain. Okay, I want you to try 3 and 4. Okay, 3 and 4. Okay, so the first one is square root. Our starting point is 2, 1. It's also our first point of our domain. Okay, and it's a closed circle. So 2, 1 is our starting point. Okay, how about 6? What do we get for 6? What is our corresponding y value? Yeah, 3, which is going to be open. Okay, so 2, 3, 4, 5, 6 is open. I know there's another one, another point right here to continue just knowing the trend of the graph. Okay, that's all we're seeing. We're not seeing, the arrow in another direction. We're looking at the piece. So can you tell me what the range will be just of that restricted domain? What would the range be? John? range. Good. Okay. 1 comma 3. 1 has the bracket, 3 has the parenthesis. Okay. How many of you did get that for the third one? Good. Now the fourth one. What's different about this restricted domain? What do we see now? Yeah. We have infinity, right? This is also, if I was to write it this way as well, means the same thing. Okay. So now we have infinity. So that means we are not going to have a start and ending point. We're going to have an arrow of some sort. Our vertex was negative 2, 3. The only value I could plug in is 2. So if I plug in 2, what is my corresponding y value? Rory? Negative 1. Good. And it's going to be a closed circle because there's a bracket. Okay, so we have negative 2, 3. 2, negative 1. Okay, how do I continue this graph? What do? I know the vertex. What else do we know about this equation? Yeah, Campbell. We know the slope, which is what? Negative 1, which makes it reflected too. So if we start from the vertex and use down 1 to the left and right, we are going to get our full graph. But on the left-hand side of that V, what do I have to include? An arrow. Excellent. Okay. What would be the range of this graph? What would be the range? Yeah, Sam. Good. Negative infinity, 3 with a bracket. Okay, yeah.
Wait, how did you get 2 for like the... Oh, is that the...
Domain. It's given to you right here.
Oh, so you wouldn't plug in 2 for... I'm just confused because like infinity, it's like...
So there's not another point we could plug in, right?
Oh, so you just do the 1 point.
Just do the 1 point and then use all the characteristics we have used to graph these things. Use that to create more points, or just plug in x values on one side and the other.
Okay, so because infinity, you'll just have 1.
You'll just have 1 point that you would have to definitely plot. Okay, and that's going to be that 1 point you graph is your restricted domain. Okay, all right. So let's look at. Okay. We're going to skip around a little bit because the reason we're doing all of this, if you could look at page 5, okay, this is the reason why we're doing this. Okay, we are getting familiar with restricted domain because by plugging in values to see where our starting or ending point is, because we're doing something called a piecewise function. Okay, a piecewise function is made up of 2 or more equations using different parts of its domain. Okay, so if you look at this example, there's 3 equations given to you. Positive linear function, horizontal line, and a negative linear function. However, the domains are different. Okay, so if you look at this graph, when x is less than 0, if I plug in 0, my starting point is 0, -2. And it's an open circle because it's not equal to. Then to find the additional points, I would plug in an extra x value less than 0 to get this graph. -1 is a horizontal line, but if you notice, it's from 0 to 3. 0, closed circle, 3, open. Okay? Then I do the last one. So you have 3 different graphs on a restricted domain to create a function. Okay? So, piecewise graphs still abide by this idea. You're still using the vertical line test. So no matter what we're creating, you're creating another function. It's always going to be a function. Why? If you look at this example, why is that still a function? Why is that example still a function? Andrew? Okay. Yeah, Rory. Right, there's no overlapping x because we have one open, one closed. If they were both closed, would it be a function? No. Okay? So, what I want you to do, for A and B, graph them like we were just doing. Okay? A is a linear function, 2x plus 1, on domain, when -infinity is heading to 1, with a bracket. Then we have a quadratic. Okay? I want you to graph those two functions separately. Okay? Line first, quadratic second. Go ahead. Okay. How many of you did get both of these graphs? Okay. So the first one is a linear function. You plug in your starting point at 1. 2 times 1 is 2, plus 1 is 3. Okay, then if you were to plug in 0, which is less than 1, you would get 0, 1 in this direction. So the one thing with the lines, make sure you're plugging in x values that represent the domain. So if it's x less than or equal to 1, you should plug in 0, -1, so on and so forth, to show the direction of the graph. Okay? Then for B, you know the vertex is 2, -4, and I have an open circle at 1, -3. Well, if I know 1, -3, since my A value is 1, I also know 3, -3. Okay? And I continue. So now, you take both of these pieces and graph them together on the same graph. So basically, I am taking, this whole function, let's see if it works. All right. 1, 3 is here with a closed circle. Okay, then you're taking this graph, and at 1, -3, I just have to update and graphing it there. So, this is open circle, okay, and then you have the closed circle, 1, 3. This is your piecewise function, okay? That is your piecewise function, and this is what it looks like in an equation. If you were given this, you have to do the same thing as we did the two separate. So what you would do is notice what number they have in common is what in their domain. 1. That's kind of like your boundary line. 2x plus 1 cannot go past to the right of 1. Okay? It has to stay in this region. Okay? So what you would do always, substitute that number into the equation, graph that first, then do the same thing here. That is a piecewise function. Any questions? Yeah, Andrew.
So, like, if you look, like, in 1A,
Yep.
you found, like, the other one, it was, like, you plugged in 0 and graph.
Yep.
You have to do that for Piecewise, or you can just graph,
Yeah.
like,
So you could graph all of that, right? But you want to make sure you have enough points to show the shape of the graph. So if you remember the type of tricks for absolute value, which is the slope, or for quadratics, do it. Okay. If not, then plug in a few x values so you could see the shape of the graph. Okay. Okay. So you guys are going to try. Hold on. Let's see. All right. What time is it? 31? All right. Trying to think. You guys have had it today. I could tell. Okay. We're going to stop right there.